So perhaps it's great to give, but are we hardwired to be selfish? You don't see many rabbits, lions, water buffaloes or wombats politely stepping back from the waterhole going, "After you, my dear chap." Surely to survive, we have to have our own self-interest as our prime motivating factor. Are we ruled by selfishness? And what motivates caring, sharing behaviour? Who better to discuss this than a philosopher of science who focuses on psychology and biology? Professor Paul Griffiths works out of the Department of Philosophy at the University of Sydney and also manages somehow to also be a professor of the philosophy of science at the University of Exeter in the UK. He is the author of What Emotions Really Are. Please welcome Professor Paul Griffiths.
Good morning. So the quotation that I've got up on the screen there is one of the two most famous passages in the works of Darwin discussing the evolution of morality. It's from one of two books that Darwin wrote at the end of his life, in which he tried to extend his theory of evolution to apply to human beings, The Descent of Man. What Darwin was trying to do in both of these books, his book The Descent of Man the next year and his book on the evolution of the emotions, was to do very much what Jane Goodall was saying earlier, to emphasize the continuity between humans and animals with respect to even the most apparently distinctive and exalted features of the human mind. Darwin, in his second book, was trying to show that our emotions have their roots in the emotions of animals. And in this book, The Descent of Man, he was trying to show that two features which his Victorian contemporaries would have regarded as the highest, noblest features of the minds of mankind, the sense of beauty and the moral sense, both found their precursors in the minds of animals, and that our sense of beauty and our moral sense could be seen to have gradually evolved out of that of other animals. The problem that he's discussing in this particular passage can be appreciated by an argument from one of Darwin's critics, a man called William Gregg, who was a Scotsman. The fact that he's a Scotsman was important, and I'll explain why in a moment. In 1868, Gregg published an article in which he argued that there was no way that the noblest, highest features of the human mind could be explained by Darwin's new theory of natural selection. And the argument sounds a little dated. Here's the way the argument went. "Look at the Scots," said Gregg. "The Scots, of all the people of the United Kingdom, have these highest and noblest features of the human mind in the most distinctive and highest form. They're frugal, they're hardworking, they're prudent, they're the most productive members of the community. But they don't have very many children. Contrast that," said Gregg, "to the Irish. They lack all of the noble features of the human mind more than anybody else in the United Kingdom, and yet they have uncountably many children. If we just left it to natural selection," said Gregg, "if you came back, left it for long enough, the whole country would be full of the Irish and there wouldn't be any of the Scots left. Therefore, Darwin's theory can't explain the highest and noblest features of the human mind." Now, we can take that argument and strip it of the particular cultural prejudices that William Gregg brought to the problem. It's an argument you'll often hear put forward today in a kind of social Darwinist framework, that it's not the people that make the greatest contribution to the community that leave the most children behind them. And this was Darwin's response. Darwin's response was to say, well, even if that's true, and he's rather guarded, he says, a high standard of morality gives but a slight or no advantage to each individual. Even if that's true, at the level of the community, if the community contains a larger portion of people who act for the benefit of the whole and not merely to advance their own immediate interests, if a large proportion of the community act for the benefit of the community, that community will be stronger. And so the idea that Darwin's putting forward here is an idea that's come to be known as group selection. that natural selection operates at the level of the group, not just at the level of the individual. And that's a central idea for the next 130 years as people try to understand the evolution of our moral tendencies. If we leap forward a century, almost all of you will have heard of Richard Dawkins, the author of the book on the right. Very few of you will have heard of the gentleman on the left, Vero Copley Wynne Edwards, an ecologist and ornithologist. If you have heard of him, it's probably only from the references to him in Dawkins' The Selfish Gene, in which he represents, as it were, the dark side, the thing which is going to be overthrown and explained away in terms of Dawkins' new theory. In 1962, Wynne Edwards wrote a book called Animal Dispersal in Relation to Social Behaviour. So you can see why it wasn't as good a bestseller as The Selfish Gene. In this book, he argued on the basis of a lifetime of ornithological observations, mostly in the Arctic and in the North Atlantic. He used to get free passages on Cunard liners to go back and forth continuously, watching the seabirds, which is not a bad way to do your research. Wynne Edwards argued that most animals had been selected through group selection to regulate their population numbers so that they would not destroy the carrying capacity of their environment, so that they wouldn't ecologically degrade the environment they lived in, so that as a group they could survive and prosper. It's 1962, 4 years before Paul Ehrlich published The Population Bomb. Wynne Edwards' work was seen as a critical contribution by a scientist to understanding a problem that was seen then in very much the way that we see climate change today, the problem of overpopulation as something which is going to basically to universally degrade the resource base and threaten our survival as a species. In The Selfish Gene, 10 years later, Richard Dawkins drew on the work of a number of biologists that had been writing in the 1960s and early 1970s to argue that the kind of process that people like Wynne Edwards had said was so important was actually biologically impossible. That there could not, under any practical conditions, be natural selection at the level of the community, that everything in evolution is produced by natural selection acting at the level of the individual. Everything is about individual success, and nothing, or almost nothing, is about community success. If you read popular science, and if you read a book like The Selfish Gene, you'll be given a historical narrative. And as somebody who works in the history of science, it's one of my particular foci, the historical story is that up until the 1960s, everybody was like Wynne Edwards, and that it took a few clear-minded thinkers to pull back the curtain, reveal the truth, and after that we were on a proper scientific track. If you read historians of science, very few of whom sadly write popular books, but if you read serious historians of science, you'll discover that things weren't really like that, that this battle over the relative importance of group and individual selection had actually gone on for a long time. Probably the most important evolutionary theorist of the 20th century was a man called Ronald Fisher, who laid the mathematical foundations of contemporary evolutionary theory in the 1920s and 30s. And in his great book, The Genetical Theory of Natural Selection, he'd come out as a very strong opponent of group selection, had argued that selection is almost always at the level of the individual organism. If you look at the people who taught Richard Dawkins, you'll see that almost all of them were strong believers in individual selection. This is back in the 1950s. Jane Goodall's teacher, Robert Hind at Cambridge, wrote in his autobiography that after being trained at the Edward Gray Institute of Ornithology, he found it almost impossible to think of evolution in any terms other than competition between individuals. So it's not true that up until the 1960s, everyone was a woolly-minded group selectionist, and then suddenly the introduction of rigorous Darwinian thought transformed the landscape. But it is true that from the early 70s through into the 1980s, the idea that group selection played any significant role in the evolution of the human mind was an idea that had almost no support within biology. It had very, very few defenders. And that's still the situation that you'll see if you get your biology from popular science texts. The idea that group selection has fundamentally been disproved by contemporary biology is still an idea that's widely propagated. I want to talk a little about why people thought group selection was impossible and how the landscape has changed again in recent years. But before that, I want to say something I think that really, if there's one thing everybody should know about the scientific literature on the evolution of morality, it's this. It's that the word selfish in the title of that book has very little connection with the word selfish as we use it in ethics, when we're talking about selfish human behavior and altruistic human behavior. We can make that point with a simple, I guess, a joke. From a psychological point of view, altruism is acting out of concern for others. Selfishness is acting out of concern for yourself, or if you show any concern for others, it's because you believe that that action will somehow ultimately come round again and benefit you. But altruism is acting out of genuine concern for others. I care about other people in exactly the same way that I care about myself. I simply want good things to happen to them because it's them. And I think Mathieu Ricard gave us a very nice summary earlier of why you shouldn't believe some of the, frankly, cheap semantic tricks that try to persuade you that no matter how much you care about other people, really it's got to be some form of selfishness. Okay? If we think about altruism in that sense, the Madonna in that picture is a classic example of altruistic behavior. She's not feeding the child because she thinks that one day the child will look after her in her old age. She's feeding the child because she has unconditional love for it. And in the same way, we might think that the couple on the other side of the screen are selfish. Perhaps they've decided to use contraception because they don't like children very much, they're kind of messy, it cuts in the time you have to go on your skiing holidays, you have to have a smaller apartment, all sort of reasons like that. We might think, well, that's kind of pretty selfish. I don't want to hang too much on that, of course. But from an evolutionary point of view, it's exactly the other way around. The woman on the left of the screen feeding her baby is exhibiting ruthless evolutionary selfishness. Okay? She's adopting it, she's being a maximally efficient machine for transmitting her genes to the next generation. She's showing no concern for anybody apart from her own genes. Whereas the woman on the right is being incredibly altruistic. She is, for no good reason whatever, reducing her representation in future generations of the population. She's behaving exactly like the animals in V.C. Wynne Edwards' book on animal dispersal, the animals which later biologists like Richard Dawkins argued couldn't really exist and couldn't really behave like that. Okay? So the evolutionary idea of selfishness has no very direct connection. Even if it's true that, even if we were to be completely convinced by a selfish gene view of evolution, you would need a great deal more argument to go from that to the conclusion that people are selfish. Okay? Pure selfish gene evolution is very good at explaining unconditional love for children and unconditional love for our immediate family, at the very least. Okay? So these two things should not be confused. Let's go on and talk a little bit about why people came to believe that group selection couldn't occur, that really all evolution is about competition between individuals. So this is a cartoon version of a famous mathematical model published in Nature in 1964 by John Maynard Smith, one of the most distinguished evolutionary thinkers of the second half of the 20th century, recently deceased. In Maynard Smith's model, there are some little animals called mice, and they're much simpler than real mice. They shouldn't be confused with real mice. And there are some very simple environments called haystacks, which shouldn't be confused with real haystacks. It's all very, very simple. Every haystack has its own little population of mice who only live in that haystack, and they don't interact with the mice in the other haystacks. There are two kinds of mice. There are evolutionarily altruistic mice who carefully reduce the number of children that they have so as not to destroy the carrying capacity of their environment. And there are evolutionarily selfish little mice who have as many babies as they can and pay no concern for degrading the resource base of their environment. Some groups have more altruistic individuals, some groups have less. If a group has too many selfish individuals, it destroys its resource base, there's nothing left for anybody to eat, and the whole group goes extinct, as you see in the middle of that diagram. Another feature of the model is that it's possible in the long term for areas of the habitat where the communities have gone extinct to be recolonized at a later point, presumably when the resource base is regenerated, to be recolonized from the successful groups surrounding it. So you can see that what we've got here is a model of the process that Darwin described in the 1870s, process in which groups with too many selfish people don't prosper, and groups with too many altruistic people do prosper. And that's meant to explain the evolution of altruism. And without going into any of the mathematics, what Maynard Smith did was to show that there's something fundamentally problematic about that idea. So again, if we look at the three columns running down the screen, we'll see that within every column, within every individual group, it's getting more and more selfish. Why is it getting more and more selfish? It's getting more and more selfish because it contains two kinds of individuals: altruistic individuals who restrain their breeding, and selfish individuals who breed in an uncontrolled manner. So even though selfish groups are doing badly, within every group, selfish individuals are doing better. And what Maynard Smith and many other theorists argued in the 1960s was that under almost all plausible natural conditions, that process within the groups would be stronger than the competition between the groups. Okay, this process is often known as subversion from within, to give it a rather dramatic title. In the last, well, really starting in the mid-80s, but particularly in the last 10 years, there's been a very significant revival of what people now still continue to call group selection. What's really happened is that people have started to describe different processes using different mathematical models, which still have something in common with what Darwin was talking about all those years ago, but are very different to this process that we've got on the screen in front of us. So here is a rather more boring cartoon of one of these models. They're called trait group selection models, and that's because they adopt so far we've used the word group in a very common sense way. A group is all the people in a tribe in Darwin. A group is all of the animals in a habitat in Wyn Edward. A group is all of the mice in a haystack. In trait group selection models, we actually have a formal definition of a group. A group is all of the individuals who are affected by the behavior of any one individual in the group. Okay, so a group, if you take this big circle here, we can call it's a collection of populations, formally call it a meta-population. And within it, we've got these separate groups. What are those groups? Well, those groups are collections of individuals such that the behavior of any individual in that group affects all of the other individuals in the group, but doesn't affect the individuals in these other groups. Okay, so that's a formal definition of a group. Now, what's driving these kinds of models is that, just as in the old models, if you have too many selfish individuals in your group, things don't go very well. Nobody cooperates, the crops don't get planted, the fences don't get built, everybody just sits at home hoping somebody else will do the work, things don't go very well. In these other groups with lots of altruistic individuals, things go reasonably well. Okay. So as a result, if we come back after a period of time, there are less individuals in the predominantly selfish groups, and there are more individuals in the predominantly altruistic groups. And that's because of a difference in the productivity of the groups. So the model then imagines not that the groups give birth to more groups, that they colonize areas, anything like we've seen earlier. Instead, the individuals just dissolve back into the general population. So there they are, all just floating around in isolation. And then they reform into an entirely new set of groups, and the process happens again. And in these kinds of models, it's perfectly possible for altruism to increase over time. It's not defeated. It's still true in this model that within every group, within a group, over time, the proportion of selfish individuals always increases. But if you go through this 4-stage process and you repeat the process again and again, across the whole population, the total number of altruists has increased under certain reasonably plausible conditions. The difference is that in the old models, groups are doing well by producing more groups. So selfish groups do badly because selfish groups go extinct, and altruistic groups do well because they colonize new areas and give birth to new groups. So it's all about groups. Whereas in these new models, selfish groups do badly because they produce less individuals. And altruistic groups do well because they produce more individuals. It's not a matter of groups making more groups, a matter of groups making more individuals. Okay, that's the key difference. Now that all sounds very hopeful, so there are now plenty of respectable biologists who believe in group selection again, although they've changed the definition of group selection very significantly. What I just want to do now is once again to emphasize that the connections between the evolution of altruism in this biological sense and the evolution of altruism in our everyday ethical sense are not very direct. So let's look at what we mean by groups. There's a quote from the leading advocate of these models, a biologist called David Sloan Wilson, trying to sum up, says basically the lesson of a century or so of research is that selfishness beats altruism within groups, altruistic groups beat selfish groups, and as he says, everything else is commentary. But let's look at some of these groups. Famous example of a biological group is all of the beavers that live in one dam. The idea is that the dam building behavior of any one beaver affects all of the other beavers that live in the same dam, but has no effect on the beavers that live in other dams. Therefore, the community of beavers living in one dam is a trait group, and we can use trait group selection to try and understand the evolution of dam building behavior. David Sloan Wilson has argued that there's a cultural evolutionary process which works in exactly the same way, and rather controversially, he's tried to use that to understand the cultural evolution of small, highly cooperative religious communities like the Amish and the Mennonites in North America. However, the mathematical model that we've been talking about is equally applicable to this group here. The group consists of one groper and one or more cleaning fish eating the parasites in the mouth of the groper. And the lifetime of the group is one cleaning session. So a group is formed when a big groper swims up to a place on the reef, and one or more tiny cleaning fish swim into its mouth and eat the parasites. And then the groper swims away, and that's stage 3 of the process I told you earlier. Okay? So some very strange, the word group has drifted a very long way from its original meaning. So the take-home message is, no, biology has not shown that we are all essentially selfish. Even the idea that we're all essentially selfish in a purely evolutionary sense is an idea that is much less generally accepted than it was back in the 1980s. On the other hand, getting from solid scientific conclusions about evolutionary selfishness to conclusions about selfishness in the sense it really interests us, in the ethical sense, takes a lot more argument. Merely settling whether or not we're evolutionarily selfish or evolutionarily altruistic is not enough to clearly settle whether, as ethical beings, we are, in the more important sense, altruistic or selfish.